Hello Year 9s, and as NAPLAN is approaching very quickly this month, I want to still work on chance and data. So I'm going to start with the standard level first of all and continue to intermediate and advanced. So I hope you still take note of these, and I wish you well. You might want to subscribe to this so that you get notified when the next videos come along. And we'll start with a very simple one. It's a die which is tossed once. What is the chance that 5 is shown on the uppermost face? If you're dealing with a fair die, there should be, as on any die, 6 numbers. And I've shown you here a net of the die. So there will be a 1 and a 5 in here, a 6, a 2, a 3 and a 4. And what you're asked to, what is the chance that 5 is shown on the uppermost face? Since there are 6 numbers on a die and 5 occurs only once, then our chance of getting a 5 on the uppermost face will be 1/6. So we can highlight D. Diane recorded the number of minutes it took to drive home from work each afternoon last week. What was the average time? So she recorded that on Monday it took her 25 minutes, on Tuesday 35 minutes, Wednesday 45 minutes, Thursday 40 minutes, and Friday 55 minutes. All in all, how many days did she drive? 1, 2, 3, 4, 5 days. So to find the average, we must add all this time together and then divide it by 5. And all these times need to be divided by 5. Now this is a non-calculator part of the exam, so we need to add all those numbers together. And the addition could be done in a vertical way. So 5, 5, 5 and 5, we get 20. 2 is over, 7, 11, 15, 18, 20. So altogether we'll have 200 minutes. And now we need to divide this 200 minutes by 5. And 20 divided by 5 is 4. So that means that 200 divided by 5 will be 40. So her average is going to be 40 minutes. We need to write that down. 40 minutes. John checked 60 players in his club to see if they paid their fees. Some of the results are shown in the table. So there were seniors and there were juniors. Out of the seniors, 8 of them had paid, and we don't know how many have not paid because we want to know how many seniors had unpaid fees. We know that juniors paid, 22 of them paid, and 13 of them did not pay. Now remember, I said that there were 60 players altogether. So we want to know the value here, let's say of X. So 8 plus 22 plus 13 plus that value of X is all going to equal to 60. Now we need to add these values up together. So that should be 43 plus X is equal to 60. And if we want to know the value of X, we should take 43 from here, take 43 from the right hand side, and we'll know that the value of X is 17. So this graph here shows you the number of computers in all the houses in the street. The horizontal line shows you the computers, the numbers of computers, like there's no computers here, 1 computer, 2 computers, 3 computers, 4 computers, 5 computers. Whereas the vertical scale tells you how many houses have them. So for instance, the very first bar shows you that 3 houses had no computers. Now, the question says how many computers were there all together in the street. So in fact, we don't even have to make use of this particular bar at all, but we do need to know the rest of it. So 6 houses had 1 computer. Here are the houses, 1, 2, 3, 4, 5, 6, and they all have just 1 computer. This represents the second bar. Now 4 houses had 2 computers, and this will represent the third column. Now 2 houses had 3 computers, shown here in green, and 3 houses had 4 computers, and that's represented in yellow. And finally, there was 1 house which had 5 computers, and I'll represent that in black. So how many computers were there all together? As you can see, you can just add this all up, or you could multiply 1 times 6. So we have 6 computers here. Then you can multiply 4 houses by 2 computers, and that'll be 8. And then you can multiply 2 by 3, which would be 6, and 3 by 4, which is 12. And lastly, you have 1 times 5, which is 5 computers. So we add them all up. 6 plus 8 plus 6 plus 12 plus 5, and that is equal to 37 computers. Down in here, 37 computers were on the street. So a jar holds 5 red, 6 yellow, 4 green, and 3 black jelly beans. And I've put them inside this jar. 5 red, 6 yellow, 4 green, and 3 black. What is the chance that it is yellow? The first thing we need to ask ourselves, how many jelly beans are there in total? And after counting, I find that there are 18 jelly beans all together. Now I'm just going to pick up 1 jelly bean out, and it has to be yellow. And how many yellow jelly beans are there? There are 6 yellow jelly beans out of 6 yellow jelly beans out of 18 beans altogether. That means it's 6 divided by 18, and we can simplify that by dividing 18 by 6 will give us 3 and 1 6, so it'll be 1/3. So the chance of getting a yellow jelly bean is A, which is 1/3. After 6 games, Sean's average or mean number of points scored per game was 3.5. How many points had Sean scored altogether? Well, if there were 6 games, and for each game he scored 3.5, so first game 3.5 plus another game 3.5 plus the third game he scored 3.5 plus the fourth game he scored 3.5, fifth game he scored 3.5, and sixth game he scored 3.5. What's that in total? Well, why don't we just do 6 multiplied by 3.5? And since you don't have a calculator, maybe we'll do this. 3.5 times 6. 6 times 5 is 33. 6 times 3 is 18. 21. Okay, where does the decimal point go? Right here. It must be moved 1 decimal point to the left because this decimal point was also 1 to the left. And so we'll write 21.